So the first thing that I'm going to do, after writing down dy dx equals, I'm separating, so dy over y squared equals negative 4x squared dx. And now I can integrate. By the way, this means this will be written as y to the negative 2 dy equals negative 4x squared dx. Which makes this y to the negative 1 over negative 1 equals negative 4x cubed over 3 plus c. I personally am going to multiply everything by negative 1 so I get rid of the negative signs. It makes my life easier.
Wait.
Yeah, because I put my square on the wrong piece. So that changes this, which then changes this, which makes this negative 2x squared. Let's try that. I personally am going to multiply everything by negative 1 because I hate dealing with negative symbols. 1 over y equals 2x squared plus c.
Wait a minute. Does the c not change sign?
But it's a constant.
It's still a
Oh, that's what it is.
It's not almost a
So the order pair was 0, 1, right? I'm plugging it now. 1 over 1 equals 2 times 0 squared plus c. Plus c equals 1. So 1 over y equals 2x squared plus 1. It's the same thing. Yes, so, ladies and gentlemen, you should have gotten 1 over 2 x squared plus 1 equals y. Here's the deal. My c may be different than your c depending on what you did for your math. Depending on how you did your math and where you plugged in c, the c's can be very different. Your final answer will be the same, but your c can look very different. I decided that I was going to multiply by negative 1 because that way I didn't have to deal with negative signs. Negative 1 times c is still c, still a constant. And then I plugged in here without solving. I don't care how you do it. That is up to you. That's what I did. I plugged in here and then solved for y after that. It doesn't matter where you find c. It is your choice. Yes, ma'am.
So when we distributed the negative 1, we put it as negative c,
Yeah, that's an issue.
and we got c equals negative 1, but when you plug it back in, it equals plus 1. Is that always going to work?
Well, it should. I say that. Usually c times a negative number is still c, so just be careful. It should. It's still constant.
Because it ends up canceling out the negatives anyway.
Right. Right.
Okay.
All right, you have one more of these. Go.
Yeah. It's basically just one function.
Oh, that's where.
Yeah, so d line equals and was this I gave you this right?
Yes. Yes.
It's not bad. Just a lot of words.
So it is a lot of words, which means you have to translate words. Here we go. So, by the way, height of the slope up does mean dy dx, right? Should know that. Alright, let's see. Should have done this. Should have done this. That makes this y cubed over 3 equals 2x squared, no, just x squared. X squared plus c. 0, 3. So 3 cubed over 3 equals 0 squared plus c. So c equals, that's 27 to 9. In my world, c is 9 because I haven't solved. So y cubed over 3 equals x squared plus 9.
Yeah.
So y cubed equals x cubed, x squared
3x squared.
equals 3x squared plus 27. If you solve for, if you got y cubed first and then solve for c, your c is 27.
Yes.
I find my c after getting y cubed. I didn't solve for y yet. This is a great case where your c would be very different. And then y equals the cubed root of 3x squared plus 27. If you can solve for y, you should. Yes. They're actually in already. Swim in this morning. I think. Oh, maybe I didn't. I thought I did.
No, you did. You did.
Okay. Then, before the end of class, maybe make sure they're written down on my grade. All right. Y'all ready? Set? Let's go. All right. So now let's go back. I want to go back over to the vocabulary that we haven't talked about. This. Go back to the vocabulary that we haven't talked about. The very front of the page. This is really important, right here. dy dt equals ky. That's a proportional. It's proportional. If it says rate of change, it's proportional to something. K is proportionate. K is constant. It's on the front page.
Yeah, I'm like,
It's on the front page on a particular solution. Okay. dy dt is y is a model for population growth. It is a proportionality. So if somebody says my rate of change is proportional to the function dy dt equals ky, that's what I would write down. Proportionality. That's more proportional. So here's what I want you to do. I want you to put that down on a piece of paper. And we're gonna integrate this. We're gonna separate and integrate. dy dt equals ky. I want you to solve. K is a constant. It is a constant of proportionality is what it's called. Its formal name is constant of proportionality. Okay? This is a proportion. Well, it's a proportion because I can write it. The rate of change is a constant times my function. We are solving. I want you to solve this. dy dt equals ky. What are you solving for, Bob, by the way? Y. You're solving for y. K is a constant. When I say solve for y, that does mean you need to do what first? Get all the y's on one side and get all the t's on the other. I don't want to solve for y on this. This is the rate of change. I want the original function. What's my actual function is what I'm asking. So we've written this down somewhere.
Did you bring the K over too?
I did not bring the K over. I left the K on the other side, so because it's a number. So why move it? You can. You don't have to. I'm not asking you to do A. I'm asking you to do this. Yeah, you need to pay attention. Yeah. This is what I asked you to do. I got it. Just want you to write this down. I want you to solve this. I didn't ask you anything about the notes. I said write this down and solve this. But I need you to go further. Yep.
Oh, okay, I got you. Yeah, no, it's C. You do the A.
just put the C in front of the E.
Okay. You should have gotten y equals c e to the kt, yes?
Yeah.
I have a question. What does t represent? Time. If t is equal to 0, please solve this.
C equals 0.
C.
C. No. Yeah. Yeah.
Y equals C.
When t equals 0, y equals c.
Yeah.
Every single time. Every single time. You know what C is then when I have it written like this, only in this form, only in this form. You know what C is?
Initial value. Only. Wait,
That's when T is 0. When T is 0. So if I tell you I am starting something with 300 people, my C would be what? 300.
Oh.
If I said at time 5 I had 300 people, is C 300?
No.
Not at time 5, it's not. This is only when time is 0. So we're okay with that. By the way, you'll notice over here we get this. And all of you are like, oh, what's A? A is the initial value. We just talked about what's A here. A is the same thing as
C.
C. Look at that. It's amazing how that works. All right. If you have a function, that population that's going to create, what's going to grow exponentially first and then level off. Okay. If you have a function that levels off, it's called a logistic model. It's going to be something like this. dy dt equals ky times 1 minus y over L, where L is what's called the carrying capacity. You know what carrying capacity means?
Yeah.
The point at which
It's maximum. It's that work on philosophy, by the way. That's sitting on top of a logistic configuration. It's the maximum that I can put in something. By the way, you know what has something like this? The initial population growing exponentially and then dying off and then leveling off? Humans, but more like a fish tank. A fish tank, because a fish tank can only hold so many fish
Before they all die off.
before they start to die off. So they have a carrying capacity. Okay. At some point it levels up because you can't, and then it starts decreasing. Yes. So we're going to talk about the other one in just a second. No, we got a little sign. Okay, here we go. An initial population. Everybody listening? An initial population of an element is 1,000 grams. So an initial amount. An initial amount of an element is 1,000 grams. It grows exponentially at a rate of 3% per day. Okay? So let t, y equals y of t, so y is my function. That's what that says. Be the number of grams represented t days later. Initial value problem. No. Well, I haven't got the initial value problem.
Y equals 1,000.
Nope. Initial value problem.
only 1,000. I would just say
Initial value problem has two pieces. There's the initial value piece. The problem is dy dt equals what? Nope.
No, you can't use
dy dt. But, ladies and gentlemen, remember dy dt. What did I say dy dt was for population? What? Here's my question. Do I know how much I'm growing? What the rate of change of the what the growth rate is? Growing exponentially. 3%.
Yes.
0.0.
So, I need to have this, and I need to have this, or this. I don't care which one of those two. You need to tell me the initial value, and it needs to be the rate of change. Whose solution, because here's the key thing, ladies and gentlemen, it says, whose solution is y of t. Meaning, I need to get to y of t, but I'm not there yet. Solution means I've solved for it. I haven't solved for it, which means I need the derivatives first. Yes?
Would it not be like 1.031?
No. It's not. Not for these. Alright. So here's my question. From this, can you write me the formula for y of t?
Yeah.
You should be able to. That's the answer for A. Those two pieces.
So the integral of
Part B is easy. Now, you can actually separate, you can actually integrate. By the way,
Life's hard, man.
K.
This direction that you like in keeps it.
And then you get 7 sharp.
Now, do you have to show me all of this,
You know that
or can you just go from here to y of t equals ce to the kt, and then write y of t equals,
What are we doing?
Wait, I don't understand. I thought we were taking
yes,
isn't it 1.0? Because it's going.
I have a 0.03. I'll think about it, and I will,
Because it's 1.03.
no, it's a positive number. Let me think about it. Right, my answer he has this, and I need to go back and look again. But right now, I did it as 0.03. I will let you know. You need to give me a couple minutes, but I'll let you know it's 1.03. But I'm pretty sure it's 0.03.
Okay, thank you.
Yeah. How long does it take for the initial population to double?
Oh, wait.
Did it equal to 2? Yes. Why 2,000? Because that's double the initial value. Ladies and gentlemen, do you have your calculators out? Get them out. And I want you to go.
What is wrong with me?
Right. Because if it's 1.03, it's a lot.
It's a massive number, okay? So I thought.
One day.
If it was decaying, it would be a negative, and if it's a positive, but it's not 1.03 because of E, I think.
So it's straight shot calculator.
This would be calculated, yes. Yes.
So the reason why I did